Yes, sir.
Uh,
Yes, sir.
is my is my screen visible to you?
Yes, sir. Yes, sir.
Okay, all right. See, so what I was saying that we have discussed in our previous lecture frequency response. We discussed that an amplifier would behave differently for a different frequency. So for low frequencies, amplifier would behave differently, and for high frequency signals, it would behave in a different fashion. Okay. So this gives rise to the discussion of low frequency response of an amplifier and high frequency response of an amplifier. Okay. So before we will go for the frequency response of an amplifier, I would like to mention that first let me tell you some basic terms about amplifier. So I have drawn an amplifier here, a basic amplifier. Okay. This is the block representation of amplifier. This one, the yellow one, it is the block representation of amplifier. This amplifier could be a BJT, or it could be a FET, or it could be a MOSFET. So whatever it could be, but in general, I am showing a block representation of an amplifier. I have not discussed what it is. Obviously, in our discussion, it would be BJT. Okay. Now, the job of the amplifier is to increase the strength of a weak signal, weak AC signal. The job of an amplifier is to increase the strength of a weak AC signal. Okay. So if we have a weak input signal, AC input signal, which is V in 1, and it will result a stronger output, which is V output 1. Okay. Similarly, if we have a different AC signal, okay, which is V input 2, it will result a different output, which is V output 2. Okay. Maybe V output 1 is stronger than V output 2, or V output 2 is stronger than V output 1. Okay. But one thing is clear that they are different. They are different because their inputs are different. So once any one of you wants to use an amplifier, if you want to use an amplifier, okay, then you have to ask yourself, am I audible to you?
Yes,
Yes,
sir.
sir. Yes,
Yes,
sir.
Okay.
sir.
So you have to ask how much strength should be increased for my input signal. So the first question you will ask is how much strength you want to increase. That will be defined by the parameter which is known as gain of the amplifier. Because see, from the top, you have input V input 1 and you have output V output 1. Okay, here. Now see, what is the gain? Gain is how much you have gained. Gain is how much you have increased your signal. Gain is always equal to output by input. Okay, output by input. Now, what is output, which is VO1? What is input, which is V in 1? Suppose this is 1 volt. Okay, for example, this is 1 volt. And suppose this is 10 volt output. So we have 10 volt divided by 1 volt. It will be 10. Okay, gain does not have any units. Gain is unitless quantity. Okay. So for this system or for this amplifier, you are actually increasing the strength of your input AC signal 10 times. Okay, 10 times. Suppose a person would like to have an amplifier where he wants to increase the strength of the weak input signal 20 times. So the gain of that amplifier would be 20. Gain of that amplifier would be 20. Okay. Now you have to understand that gain is very important quantity in amplifiers. Gain is very important quantity. Whenever you select the amplifier, you have to first think which gain should be present in the amplifier. How much this amplifier should be capable of increasing the strength of my weak signal. What could be your weak signal? Your weak signal could be, a signal which is picked up from the body, from the scalp of the skin, or maybe any other a signal from your microphone, or any other weak signal that is present in your nature, maybe a weak signal from your sensor or your transducer. We don't know. Okay, there are a variety of examples for that. But gain is very important. Gain is very important. Okay. Now, there is another thing. This is one aspect. Gain is very important thing for an amplifier. So an amplifier, one amplifier would have one gain, another amplifier will have another gain. It is not necessary that all the amplifiers will have same gain. One amplifier can have one gain, another amplifier can have another gain. तो ये तो एक चीज है. The second thing that you have to remember that now see, if for example you have an amplifier here, okay, this is its input side, this is its output side. If you are applying a signal of, for example, 1 volt, okay, what is the amplitude? Amplitude is equal to 1 volt here. Amplitude is equal to 1 volt here, okay. Suppose the gain of this amplifier is 10. Its gain is 10, okay. Gain is, by the way, generally represented as A also. A is gain, okay. So suppose the gain is 10. Suppose the gain is 10. So gain is A. A is gain. Suppose, so I am showing here amplifier with gain A. Okay, amplifier with gain A. So A is the gain. A, generally gain is represented by a letter A. Suppose this amplifier has gain 10. This amplifier has gain 10. I'll ask 45, roll number 45, what will be the output? What will be the amplitude of my output? Roll number 45, what will be the output of, what will be output?
Sir,
My gain is 10. How much
sir,
will be the output?
sir, 10.
It will be 10 volts. Very good.
Yes.
Because the amplification is now 10 times. Okay. Amplification is now 10 times. Now see this time period. Time period is this much. What is time period? Okay. Time period is the duration of each cycle. Just a second. Time period is the duration of each cycle. So it has a time period equal to t. If I ask you what is the frequency of this signal, you will say frequency is equal to 1 by time period. Okay. And say, for example, its time period is t1, its frequency is f1. Now, please remember that if we will apply a different signal to this amplifier, अगर इसको एक दूसरी signal दी जाएगी यहाँ पे input पे, okay, you will apply a different signal to this is, for example, V input 1, okay. We will apply now V input 2. लेकिन ये जो ये signal है, it has a very higher frequency. Higher frequency means it has a different time period, which is T2. It has a different time period, which is T2. Its frequency will be equal to F2 equal to 1 by T2. Now see, as compared to uh, as compared to the signal V1, V2 has higher frequency. Okay, it has higher frequency. Why? Because the duration of the cycle is small. Okay. Now we are expecting that output will be also like this. Output. Now suppose this also has 1 volt amplitude. It has also 1 volt amplitude. Okay. So we are expecting that our output will be 10 volts now because the gain is 10. But practically this does not happen. Amplifiers, they are highly frequency specific. Please remember this once for all. Amplifiers are highly frequency specific. ये एक सिग्नल को जिसकी फ्रीक्वेंसी एक होगी, they watch it, they consider it in a one way, and if you change the frequency of the signal, they do not provide you the gain, same gain, they provide you a different gain. ऐसा भी हो सकता है for 10 for this frequency f2, the output will be not 10 volts but it will be only 8 volts. ठीक है, तो इसका गेन अब कितना है, यहाँ पे इसने गेन दिखाया 8, एक्चुअली गेन था इसका 10. So frequency, these amplifiers are very highly frequency specific. यानी frequency input signal की जो frequency है, they have a very high impact on these amplifiers. That is why we are studying low frequency response and high frequency response. यानी एक amplifier low frequency में कैसे behave करेगा and high frequency में कैसे behave करेगा. अब जो ये frequency discrimination है amplifier में, you know, we say that, I'll write it down here. Amplifiers, कोई भी amplifier, whether BJT, whatever it is, amplifiers react, yeah, provide a different gain in different frequencies. ठीक है, अलग अलग फ्रीक्वेंसीज में ये अलग अलग गेन करते हैं प्रोवाइड. If you, and that is, one amplifier could give you a good gain in one frequency, maybe this amplifier will not give you a good gain in another frequency. Okay, it will not give you an another frequency good gain. Now see, we have a different plot which is known as gain versus frequency plot. ये एक बहुत important plot है जो हम when once we study the gain frequency response of these amplifiers, this plot helps us to understand the behavior of these amplifiers with respect to the frequency. ठीक है? So I will draw a plot here. You will try to understand what I am drawing. So every, like you have an identity card for a person, human being, every amplifier has its own gain versus frequency response plot. ठीक है? Gain versus frequency response plot. Say for example, I'll mark this is frequency axis. Frequency axis. इसमें x axis gain versus frequency plot में x axis हमेशा frequency होती है, which is in, say for example, hertz. Okay, it is in hertz. Its y-axis is always gain. What is gain? Gain is V output divided by V input. Okay, V output divided by V input. Generally, we say that gain versus frequency response of an amplifier, it is like this. Okay, see, for zero frequency, that is here. So this is a zero frequency. If the signal frequency is zero, what is signal known as? It is known as DC signal, because here frequency is zero. So DC signals में frequency zero होती है. So they generally provide you at lower frequencies, they provide you lower gain. Then there is a constant gain up to certain frequency, then the gain also falls off. तो generally जो हमारा gain versus frequency response होता है वो ऐसा ही होता है. ठीक है, तो please note that here you have two areas, okay, or three regions. One is lower frequency region, the another one is medium frequency region, the third one is high frequency region. Okay, high frequency region. Now high frequency response जो हम ऊपर कह रहे थे, low frequency response and high frequency response, this actually pertains to these two areas. This is the low frequency response of the amplifier, and this is high frequency response of the amplifier. This is what we are going to discuss in next few minutes, or probably in our next lecture also. Okay, now if you have a question that why the amplifier behaves like this, okay, I'll give you an example how it behaves like this. Now I'll first tell you, generally amplifiers are of three types. Okay, या उनमें coupling तीन तरीके की होती है. We have three types of coupling in the amplifiers. One amplifier is known as RC coupled. What is coupling? Coupling means how you connect one circuit with another circuit. How you connect an amplifier. See, for example, you have an amplifier. I'll first tell you direct coupling. Okay, I'll first draw direct coupling. Say for example, you have an amplifier here. Okay, this is an amplifier. This is its output. This is its input. Now see, input will come from source. Input will come from certain source. ये source amplifier के साथ कैसे connect किया गया है? How is the source connected to the amplifier? And output will be connected to a load. Now see, here the source is connected directly. Connection is direct. So that is known as directly coupled amplifier. Okay, here the source is connected directly and the load is connected directly. The connection is direct. That is why it is known as directly coupled amplifier. Okay, Now in RC coupled amplifier, you can expect now another thing. In RC coupled amplifier, you have an amplifier here. This is its output and this is its input here. Okay, somewhere here. And you have a load here. Okay, then you have a source here that will give you input. Now the source is connected with the amplifier with the help of a capacitor. The load is also connected with the amplifier with the help of a capacitor. These capacitors, they are known as coupling capacitors. CC means coupling capacitor. Capacitor. Okay. CC means coupling capacitor. So this is first C, this is second C. CC means coupling capacitor. Now see here the connection between the load and the source, it is through the capacitor. Then this kind of uh, amplifier, it is known as RC coupled amplifier. Okay, RC coupled amplifier. It is actually capacitive coupled amplifier. If you say why it is known as RC coupled amplifier, it is known as RC coupled amplifier because here the amplifier is generally like this. See, I'll draw the output stage. You have output capacitor here, C, coupling capacitor. Then you also have a resistor. Okay, what is the resistor? It is load resistor. Since you have R and C at the output, then this is output, V output. You can measure V output here. So that is why it is known as RC coupled amplifier, or you can say capacitively coupled amplifier. Generally, you can say capacitively coupled amplifier. Capacitively coupled amplifier. ये क्यों करते हैं यूज, मैं आगे इसका जवाब दूंगा. I'll tell you. Okay. The third class, which is also known as the third class is known as transformer coupled amplifier. Oh no, okay. This type of classification or this type of amplifier would be very easy for you because you know transformers. Okay. Here you have an amplifier. You have an amplifier here. Okay. So we have an amplifier here like this. Your amplifier is connected to your load using uh, a transformer. Okay, using a transformer. So it is connected with your load using a transformer. This is load resistance. Okay, this is V output. क्योंकि इसमें ट्रांसफॉर्मर कपलिंग होती है, डायरेक्ट कनेक्शन नहीं है. ट्रांसफॉर्मरली कपल्ड होते हैं आउटपुट सर्किट और एम्पलीफायर का सर्किट. Maybe you have N1 turns here, okay, is to N2 turns here. So that is why it is known as transformer coupled amplifier. Okay, that's why it is known as transformer coupled amplifier. It is known as transformer coupled amplifier. Now see, it is known as transformer coupled amplifier. Now, for both of these, RC coupled, direct coupled, and transformer coupled amplifiers, they have a different gain versus frequency response. Okay, इनका अलग अलग होता है. मैं वो आगे बताऊंगा कैसे होगा. फिर हम लो फ्रीक्वेंसी और हाई फ्रीक्वेंसी पे जनरली बात करेंगे. But this is how these are amplifiers actually. Okay, three types of amplifiers. They have a gain versus frequency response like this. So gain versus frequency response is just like a DNA, print of an amplifier. It defines how the amplifier will work. So this is voltage gain, for example. Okay, magnitude. So this is frequency. RC coupled amplifier ka gain versus frequency response is generally like this. It is generally like this. Okay. डायरेक्ट कपल में क्योंकि कैपेसिटर नहीं होते हैं, डायरेक्ट कपल, in direct couple we do not have capacitors, the frequency response, it looks like this. It looks like this. I will explain everything why it looks like this. Okay. For transformer coupled amplifier, you have frequency here and you have gain here. Say for example voltage gain, it looks something like this, sometimes like this. Okay. So you have somewhere here where you have resonant effect, because transformer is also an inductor. Okay, transformer acts as an inductor. When you have circuits, inductors and resistors in your circuit, you have inductors and you have resistors in your circuit, then there is, and sometimes there is a resonant effect. ठीक है, मैं ट्रांसफार्मर कपल्ड पे बिल्कुल बात नहीं करूंगा। आई विल प्राइमरली डिस्कस आरसी कपल्ड, डायरेक्टली कपल्ड में भी थोड़ी मैं बात करूंगा। बट दिस इज हाउ गेन वर्सेस फ्रीक्वेंसी रिस्पॉन्स of the amplifier will look like. Okay, gain versus frequency response of the amplifier will look like. So let us discuss RC coupled first. So I have drawn here actually, जो मैंने यहाँ पे आपको gain versus frequency response बनाया है, it is for RC coupled amplifier. Okay, it is actually for RC coupled amplifier. Is it fine? Okay. Now see, I will draw an amplifier now, a well-established circuit of an amplifier. Then I will tell you why it happens like this. Okay. So let me draw an amplifier first somewhere here. See, if we draw an amplifier using BJT, so we have a BJT here. Okay. You know that in BJT, we have this resistance. It is known as emitter resistance. We have output resistance here. This is VCC. This is collector resistance because you have collector. This is emitter. Resistance connected to emitter is emitter resistance. Resistance connected to collector, it is RC. Then you have another terminal here. You have another terminal here which is known as gate terminal. Bilal, roll number 11. है ना ये gate? Roll number 11. Okay, roll number 11
Yes,
is
sir.
not here. Is it gate?
No, sir. Base.
Base. Okay, it is base. Very good. Now see, this is an amplifier generally. ठीक है, हमने पीछे कहा था, हमने शायद 3 बायसिंग मैंने थोड़ा सा उसका तज़किरा किया था, फिक्स्ड बायस, सेल्फ बायस, कलेक्टर टू बेस बायस एंड वोल्टेज डिवाइडर बायस। ओके, मैंने कहा था कि बायसिंग एम्पलीफायर में बहुत इंपॉर्टेंट है। We have also discussed that biasing is used to fix the Q point. Okay, now we have biasing here, तो अभी हमें biasing इसमें करनी है। So let us go for a voltage divider bias. Okay, voltage divider bias. So you have R1 here, R2 here. So this voltage will be VB, and this will give fix, this voltage will fix Q point. Okay, so its Q point will be somewhere, say for example IC comma VCE. Okay, and it will fix the amplifier's Q point. I have not gone into the analysis of Q point because I don't think we have that much time. आपके सिलेबस में इतना ज़्यादा इसमें लिखा नहीं गया है. But this is how the amplifier will look like. Okay, लेकिन ये amplifier सिर्फ amplifier है जिसमें बायसिंग की गई है. इसमें कहीं ये तज़किरा नहीं किया गया है where is input applied and where is your output, where from your output is taken. Okay, so अभी तक हम इतना ही करते थे, but please remember output is always taken from collector, and output, if it is taken through capacitor, then this is a capacitively coupled amplifier. Okay, so this entire region, I think I should mark this one. I should mark it like this now. This is your amplifier. Okay, this is your amplifier. This is amplifier. अभी इसमें सिर्फ आउटपुट टर्मिनल हमने किया है मार्क. ओके, सो जो 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 एम्पलीफायर में बना रहा था वहां पे लाइक दिस इज आउटपुट टर्मिनल एंड इनपुट टर्मिनल. इनपुट मैंने नहीं किया मार्क लेकिन आउटपुट किया मार्क. So input is always applied at base. Okay, and input, since it is applied at base, and it is also applied using a capacitor, so you have always here input signal, and this is a sinusoidal signal that is to be applied here. Okay, then only if it is a common emitter, there will be a 180-degree phase shift. There will be a 180-degree phase shift. Okay, so then only you will have output here which will be amplified and sinusoidal if you have input sinusoidal. Okay, and phase difference will be 180 degree. Common emitter में मैंने कहा था जब हम इनकी configurations पढ़ रहे थे, I said that the phase difference between input and output is 180 degree when you have common emitter configuration. Please remember that this is a common emitter configuration. Okay, this is common emitter BJT amplifier. Okay, now see here, why do we apply this coupling capacitor? इसमें coupling capacitor क्यों लगाते हैं? इसमें coupling capacitor क्यों लगाते हैं? Coupling capacitor इसलिए लगाते हैं because दिस वीबी जो है, व्हाई आर वी अप्लाइंग वीबी हम इसलिए अप्लाई करते हैं ताकि हम क्यूसेंट पॉइंट को फिक्स करें. ओके, सो वीबी इज अप्लाइड टू फिक्स क्यू पॉइंट. ठीक है, टू फिक्स क्यू पॉइंट, एंड क्यू पॉइंट शुड बी स्टेबल, एंड क्यू पॉइंट must be stable. It should not change. ये कभी चेंज नहीं होना चाहिए. ओके, आपको पता है क्यू पॉइंट हमारे आउटपुट कैरेक्टरिस्टिक्स में एक पॉइंट होता है. क्यू पॉइंट हमारे आउटपुट कैरेक्टरिस्टिक्स में एक पॉइंट होता है. दिस इज द आउटपुट कैरेक्टरिस्टिक्स ऑफ द बीजेटी जो हमने ऑलरेडी की है. ठीक है, तो यहाँ पे आप कहीं क्यू पॉइंट लगाते हैं. अगर ये चेंज हुआ, यहाँ से यहाँ पहुंचा या यहाँ से यहाँ पहुंचा है, यहाँ से यहाँ पहुंचा, आपको पता है क्या तूफान आता है. इसमें पूरा गेन कम हो जाता है. ओके, the amplifier does not behave in the similar fashion. So Q point must be stable, that means stationary. ये चेंज नहीं होना चाहिए. Why? अगर ये चेंज होगा, then the gain of the amplifier will change. Okay, and what makes Q point stable? That is VB. Okay, VB, that is biasing voltage, makes Q point stable. Okay, now see, Q point को जो stable करता है, VB करता है stable. So if VB is constant, अगर VB constant है, if VB is constant, then Q point will be also constant. Will be constant. Okay, if VB is variable, yeah, it changes, then Q point will also change. It will also change. Okay, Q point will also change. That is why we are using a fixed bias. हम fixed bias configuration इसलिए कर रहे हैं use क्योंकि उससे VB हमारा fixed रहेगा. In fixed bias, we know that it is a voltage divider network. In fixed bias configuration, it is a voltage divider network. So VB will be constant. Why? Because VC, it is constant. When VC is constant, then VB will be always constant. Okay, VB will be constant. When when VCC is constant, then VB will be constant. And we want VB should be constant. We want VB should be constant because Q point has to be constant. If VB will not be constant, if VB will change, then Q point will also change. वो ऊपर नीचे जाएगा. Okay, that will also change. That will also change. Now this is one aspect. Okay, now see, I'll draw this amplifier here again, this amplifier, but only the input side. See, this is my coupling capacitor. This is a point where you have resistor R1. This is VCC. This is a point where you have R2. Okay, then say for example this is grounded. आप यहाँ से देखेंगे, it is the same. Then this goes to the base. Okay, this goes to base. This is VB. Okay, now see, this will be VB will be constant. If VB will be constant, that means it will be a DC voltage here. VB DC voltage है. तभी जाके जब हम बायसिंग पढ़ते हैं बीजेटी की, हम उसको कहते हैं डीसी एनालिसिस. डीसी एनालिसिस मींस वी आर ट्राइंग टू फिक्स द क्यू पॉइंट विद द हेल्प ऑफ डीसी सिग्नल्स. ओके, व्हाई विल बी VB DC? बिकॉज VC इज आल्सो डीसी. VC इज आल्सो डीसी. अभी हमने इनपुट अप्लाई नहीं किया. ओके, अभी हमने इनपुट अप्लाई नहीं किया. अब देखिए, अगर हम यहाँ पे इनपुट करेंगे अप्लाई लाइक दिस, if we will apply certain input here like this, which is an AC. तो ये AC, since you have an AC signal, it will pass through the capacitor. It will pass through the capacitor. Why? For AC signals, capacitor acts as a short circuit. Okay, ये आपको पता है. I'll write down here. For AC, capacitor acts as short circuit. So if you will apply AC now, it will pass through the coupling capacitor CC, it will reach the point VB. Okay, जब ये VB पे पहुंच जाएगा तो इसको बनेगा shifted AC. इसको बनेगा because DC plus AC will become shifted AC, and that is good because we have VBE already here. VBE is equal to 0.7. Normally हम weak signal तो pass ही नहीं करती VBE को, हमें shifted AC ही लानी थी. So that is good. Okay, it will be very good. Now the another case is if I have another case is like this. If I have already a shifted AC, that means I have a AC signal with DC. ओके, अब विद डीसी है. अब देखिए जब ये जाएगा ये तो पास हो, जब अगर यहाँ कैपेसिटर नहीं होता, if there would not have been any capacitor, what will happen? Our resultant signal will be C like this. एक तो ऑलरेडी कुछ डीसी लेवल थी रेड कलर की, वो यहाँ पे थी. ओके, देन and you have some DC voltage also, DC component also present in this input. तो ये ऐड हो जाएगा, फिर आपकी ज्यादा शिफ्टेड AC बनेगी. ओके, और यहाँ पे जो VB था, अब ये VB था. ओके, दिस रेड लेवल वाज इक्वल टू VB. अब नेक्स्ट जो बनेगा वो बनेगा VB प्लस V इनपुट DC. ओके, अब वो जो दोनों ऐड हो जाएंगे वो असल में VB नहीं रहेगा, ये बनेगा VB डैश. ओके, VB डैश. नाउ VB has changed. VB has changed. What will then be changed? Q point will change now. जो हम चाहते ही नहीं है, Q point will change. So Q point will be now in order to stop this, in order to stop the in order to stop any DC component present in the input AC signal, we connect a coupling capacitor which is CC. तो now we have a capacitor here. जब हम कैपेसिटर के थ्रू इसको पास करेंगे, it will block the DC component and it will only allow AC component to flow. So because of capacitor, what you will have now, you will have only AC. Okay, और जब वो यहाँ पहुंच जाएगा, now it will have, you will have here, this will create this kind of signal with certain VB, then you have AC. Okay, then you have AC input signal. Okay, this is what will happen. So please remember that coupling capacitors are actually connected to stop any possible DC signal that is present in the input side. Okay, coupling capacitor जो हम लगाते हैं यहाँ पे, वो इसलिए हम लगाते हैं ताकि accidentally, by accident, if there is some DC component present in input signal, in input AC signal, we need to stop that. Why do we need to stop that? Because they will disturb our VB. If they will disturb our VB, that will disturb our Q point also. Okay, it will disturb our Q point also. I will ask students if you have any question. You can ask them, otherwise I'll stop here.